Hey everyone, Adam Infinity here. Welcome back to Singularity Today. Today we're diving into a fascinating collection of research papers that are pushing the boundaries of artificial intelligence in some really exciting ways. We'll be talking about how researchers are developing new ways to train robots, create realistic 3D models of the inside of the body, and even build AI that can understand complex legal documents like a super smart tutor. Get ready to learn about some incredible advancements in AI that are shaping the future as we know it. In the research titled RoboTwin, Dual Arm Robot Benchmark with Generative Digital Twins, early version, the authors address the challenge of training dual-arm robots for complex tasks such as tool use and collaboration with humans. They recognize that training these robots effectively requires a lot of specialized data, which is hard to get. So they created RoboTwin, a unique dataset that combines real-world robot data with synthetic data generated from virtual replicas of the robots called digital twins. This is a big deal because it means we can have more data to train robots without needing to actually record them in real-world scenarios, which saves a lot of time and resources. The research also introduces a clever way to create these digital twins using artificial intelligence to turn images into 3D models, and they use language models to generate realistic training data for robots. In short, this research is about creating better training data for dual-arm robots using a clever combination of real and virtual data. This could lead to robots that are more capable and versatile, which could be used in a wide range of real-world applications like manufacturing, healthcare, and even our homes. In the research titled UC-NeRF, Uncertainty, Aware Conditional Neural Radiance Fields from Endoscopic Sparse Views, researchers tackled the challenge of creating realistic 3D reconstructions of surgical scenes using limited endoscopic camera views. They introduced a new technique called UC-NeRF, which accounts for the uncertainty inherent in the sparse data. Imagine trying to build a puzzle with only a few pieces. UC-NeRF is like having a special tool that helps fill in the gaps and makes a more complete picture. This approach is particularly beneficial for minimally invasive surgeries, where visualizing the internal anatomy is crucial for successful procedures. The research demonstrated that UC-NeRF outperforms existing techniques in generating accurate 3D reconstructions, contributing to better planning and decision-making during surgery. This technology could potentially improve surgical outcomes by enabling surgeons to better understand the anatomy they are operating on and make more informed decisions during procedures. In the research titled Masked Diffusion Models are secretly time-agnostic masked models and exploit inaccurate categorical sampling. The researchers take a deep dive into masked diffusion models, NIMs, which are popular for generating discrete data like text. They find that these models, unlike traditional diffusion models, don't actually rely on the time variable, a key aspect of their design. Instead, they are more akin to simpler models called masked models. The researchers propose a new method called the first hitting sampler FS that simplifies how these models generate data, making them faster and more efficient. They also uncover a numerical problem in the way these models are trained, causing them to be evaluated unfairly. This issue leads to a false impression that MDIMs outperform other generative models like autoregressive models, ARMs, when in reality the comparison is flawed. This research sheds light on the inner workings of MDIMs, leading to a more accurate understanding and potential improvements in their training and evaluation. It could impact the development of more efficient and reliable generative models for tasks like text generation. In the research titled LongLLaVA, Scaling Multimodal LLMs to 1,000 Images Efficiently via Hybrid Architecture, the authors addressed the challenge of making multimodal language models, LLMs, capable of understanding and working with large amounts of images. Imagine you're trying to build a model that can analyze a whole movie. That's a lot of frames, and current models struggle with this. This research introduces a new model called LongLLaVA, which combines two types of neural network architectures, Mamba and Transformer, to handle large sets of images efficiently. They also came up with clever ways to process the images in a way that considers both the time and spatial relationships between them. LongLLaVA can process nearly 1,000 images on a single high-end graphics card, which opens up possibilities for things like analyzing long videos, understanding high-resolution images, and creating better multimodal agents that can interact with the world in a more natural way. Basically, LongLLaVA is a big step towards building smarter AI that can understand our complex visual world. In the research titled Multi-Stream Deep Learning Framework to Predict Mild Cognitive Impairment with Ray Complex Figure Test, researchers developed a new, improved way to detect mild cognitive impairment, MICE, using a popular drawing test called the Ray Complex Figure Test, RCEF. They used a combination of two approaches, one looking at the actual drawings themselves using deep learning, and the other using a scoring system to analyze how well people did on the test. This clever combination allowed them to capture both visual details from the drawings and the overall performance, leading to better accuracy in predicting MICE. They tested their system on a large data set of people in Korea and found that it performed much better than previous methods. This new tool could be really helpful in clinical settings because it could be used as a cheap and fast way to screen for MICE early on, potentially leading to quicker interventions and better outcomes. In the research titled Configurable Foundation Models, Building LLMs from a Modular Perspective, the authors explore the idea of breaking down large language models, LLMs, into smaller, reusable modules. This modular approach aims to address the challenges of training and deploying LLMs, which often require enormous computational resources and are difficult to adapt to specific tasks. The researchers propose a bricks concept to represent these modules and showcase how they can be dynamically assembled to perform complex tasks. They identified different types of modules: emergent bricks, found during initial training, and customized bricks, developed later to enhance LLM abilities. These bricks can be combined using operations like retrieval, merging, updating, and growing, enabling the creation of flexible LLMs. Through analysis of widely used LLMs, the researchers found that even existing models exhibit modular patterns with neurons specialized for certain functions. Overall, this research suggests a promising path towards building more efficient and scalable language models by utilizing a modular design. In the research titled Hybrid Imitation, Learning Motion Planner for Urban Driving, the authors propose a new method for planning the movement of autonomous vehicles in urban environments. The core idea is to combine two approaches: imitation learning, where the system learns to mimic human driving behavior, and optimization-based planning, which focuses on guaranteeing safe and feasible paths. This approach addresses a key challenge in autonomous driving: finding a balance between imitating the smooth and efficient driving style of humans while ensuring the vehicle's safety and adherence to traffic rules. The research demonstrates that their hybrid approach effectively balances this trade-off through simulations and real-world deployments. This research can have a significant impact on the development of autonomous driving systems by improving their ability to navigate complex urban environments safely and efficiently. Potential use cases include creating more robust and user-friendly autonomous vehicles that can operate in diverse urban scenarios, including crowded streets, intersections, and parking lots. In the research titled Bioinformatics Retrieval Augmentation Data, BRAD, Digital Assistant, the authors introduce BRAD, a digital assistant designed to streamline and automate various bioinformatics tasks. BRAD acts like a superpowered assistant for scientists, helping them with everything from running complex software pipelines to searching through massive data sets. The research highlights three key capabilities of BRAD: improved question answering with retrieval augmented generation, the ability to manage and execute complicated software pipelines, and the ability to distribute and organize tasks across individuals and teams. This means BRAD can generate code, search online for answers, and even automate entire workflows. The authors envision BRAD as a step towards creating a virtual twin of a laboratory where experiments can be designed and tested entirely digitally. The potential impact of this research is significant. BRAD could revolutionize the way bioinformatic research is conducted, allowing scientists to focus on innovation while automating tedious and repetitive tasks. Imagine having a virtual assistant that can not only answer your questions about specific genes or proteins, but also generate code to analyze data and even run simulations. BRAD has the potential to accelerate scientific discoveries and lead to breakthroughs in areas like personalized medicine and drug development. In the research titled, Oops, I Sampled It Again, Reinterpreting Confidence Intervals in Few-Shot Learning, the authors delve into the common practice of computing confidence intervals in few-shot learning, FLs. FL is a machine learning technique where models are trained on very limited data. The researchers discovered a flaw in the typical approach to calculating confidence intervals. They were often underestimated because they did not properly account for the variability in the data itself. Think of it this way. If you were trying to predict how many heads you would get flipping a coin 10 times, you wouldn't just look at the results of a few flips. You would need to consider all the possible outcomes. Similarly, in FL, confidence intervals should account for the full range of possible data variations. The research highlights the importance of using paired tests, which compare the performance of two models on the same data, to address this issue. Additionally, they suggest strategies for sampling tasks in a way that helps reduce the uncertainty in the confidence intervals. This research could significantly impact the way confidence intervals are interpreted in FL, leading to more accurate and reliable comparisons of different machine learning models. Potential use cases for this research include applications where data is limited, such as medical diagnostics, natural language processing, and computer vision. In the research titled R2K, Retriever Reader Generator Question Answering System to support students understanding legal regulations in higher education, the authors developed a system called R2K to help students understand complex legal regulations. Think of it like a super smart tutor for legal documents. It has three main parts. 1. Retreat Retriever. This part finds the relevant parts of a document that contain the answer to the student's question. It's like finding the right chapter in a textbook. 2. reader. This part understands the language of the document and pulls out the key information. It's like reading the chapter carefully and understanding the main points. 3. Graph generator. This part puts together the information it found in a clear and concise way, so it's easy for the student to understand. It's like summarizing the chapter in a way that makes sense. The research also created a large collection of questions and answers specifically related to university regulations called the Virgo 4K dataset. This dataset is like a practice test bank, but for legal regulations. The researchers found that their system is very good at understanding and answering questions about legal documents. They hope that this will help students better understand the rules and regulations they need to follow in their studies. This research could have a big impact on how students learn about and understand legal regulations. Imagine if you could just ask a computer any question you have about a legal document and get a clear and easy to understand answer. This could help students feel more confident and comfortable navigating complex legal documents and avoid potential problems. And there you have it, folks. A whirlwind tour of some of the most cutting-edge research shaping the future of artificial intelligence. Remember, this entire video was generated entirely by a super intelligent AI. No humans were harmed in the making of this video. Humans can finally enjoy their free time thanks to the power of automated content creation. So go ahead, give this video a thumbs up if you found it informative and insightful. Don't forget to subscribe for more mind-blowing AI updates, and leave a comment below with your thoughts on these incredible advancements. And if you're feeling extra curious, I highly recommend checking out the research papers themselves. See you next time, and remember, the singularity is just around the corner.